Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 16 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2598. Smallest missing non-negative integer after operations. So let's read the problem statement. You are given a zero indexed integer array nums and an integer value, right? In one operation, you can add or subtract value from any element of nums, right? For example, if nums is like this 1, 2, 3, right? And value is equal to 2, okay? You can choose to subtract value from nums of 0, right? So from this, if we subtract this value, right? So what is the new array that we are going to get? We are going to get something like this: -1, 2 and 3, right? So 1 minus 2 is -1, something like this, right? The max, what is max? Max is nothing but minimum excluded. M is minimum, ex means excluded. The minimum excluded of an array is the smallest missing non-negative integer in it. The max minimum excluded of an array is the smallest missing non-negative integer in it. Clear? For example, the max of -1, 2, 3, minimum excluded in this array, and the number should be non-negative, right? So here see, non-negative integers are 0, 1, 2, 3, 4, right? So 0 is here, no, so that's it, 0 is the output. The max of 103, 103, 0, 1, 2, 3, 4, 5, 6, 0 is here, 1 is here, 2 is missing, right? So 2 is the output. That's it. Smallest missing non-negative, smallest missing non-negative. So we have to start from here, right? 0, 1, 2, 3, like this, right? But we have to return here, we have to return the maximum minimum excluded. First thing, it should be maximum, right? And then it should be minimum excluded, minimum excluded, right? So let's suppose this is my number 103, right? The array, right? And let's say my value is 2, right? So if my value is 2, so if I subtract 1 and then 1 minus 2, I will get -1 here. I will get 0 minus 2, I will get -2. 3 minus 2, I will get 1, and then 1 minus 2, I can do any number of times, I can get -1. So here I'm making all the numbers are negative. So now you are going to say that no, let's return the output 0, right? You are going to say like that, right? But here, can I do that? Can I do that? Tell me, can I do that? I have to return the maximum also, maximum minimum excluded, right? So I can't simply make all the numbers as negative and then simply return 0. No, here I am not subtracting 5 from all the numbers, making all the numbers are negative and returning my output as 0. I'm not doing that because I have to return the maximum, right? And here I'm also not doing this thing like this is the value 5, I'm not adding 5 multiple times to all the numbers, like such that I'm making all the numbers very big, let's say 100, 1000, 2000, 3000, like this. So if I'm doing like this, then also your output you are going to return something like 0 only, right? In this case, if you add 5 multiple times to all these numbers, right, you are going to make all these numbers, let's suppose, very big numbers. This is a very big, this is 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 very big. Then still you will say that no, let's return 0 now. 0 is not here, since we need to return the minimum excluded positive number, right? And we have to keep it maximum, right? So we can't simply add multiple values and make it a very large numbers and then return 0, or we make all the numbers as negative and then return 0. We are not doing that. How we are returning 4 then? This is the next question, how we are returning 4 here, right? Okay, so let's understand that now, right? So let's see the constants first. These are the constants. Nums value can be negative, and nums dot length value from 1 to this. Okay, so here let's take this same array, right? But what are the values? 1, minus 10, 7, 13, 6 and 8, right? So this is your example one also. 1, minus 10, 7, 13, 6, 8, right? Same value is 5, so let's say value is equal to 5. Value is equal to 5 initially, right? Okay, so here from this number, what are the different numbers I can get? I can get 1, 1 plus 5, 6. I can get 11 also, right? And if I subtract 5, right, from 1, I will get what? Minus 4, right? These are the numbers, these are some numbers that I can get further, right, for this 1, right? Now in this case, if you notice one more thing, what is 6 molders with 5? Remainder of this is nothing but 1. What is 11 modulus with 5? The remainder is nothing but 1. What is 1 modulus with 5? Remainder is nothing but 1 here. What is minus 4 modulus with 5? Tell me, what is the remainder of this? It's nothing but 1. This one is nothing but the positive remainder, and the negative remainder is going to be minus 4 only, right? So here if you divide this minus 4 with 5, right, so what is the output you are going to get? You are going to get something like this, remainder as minus 4, right? And if we write it in the form of this division algorithm, right, a is equal to bq into r, right? So a is nothing but the number that we are going to divide here, so that is nothing but minus 4. And with which number we are dividing it? We are dividing it with the 5, right? So 5 into this quotient 0, and this is nothing but plus. Okay, a is going to be into q plus r, right? So here plus, right? So here remainder is nothing but minus 4. So see here, my LHS and RHS both are matching. This is my left hand side is equal to my right hand side. Clear? Okay, so in this case this is my negative remainder. So I can also do one thing now. I can also write it like this as well. uh, a is nothing but minus 4. B is nothing but number, this one number, right, 5. And if I write this q, right, if I write this q as, okay, but here first see remainder here in the top I am returning it 1. Okay, here I am returning it 1. So here what should be the value? What should be the value? Here I can do one thing. I can write it minus 1, right? If I write it minus 1, okay. So now if I do this, minus 4 is nothing but minus 5 plus 1. So minus 4 is equal to uh, here minus 4. So now also my LHS is matching with RHS. So in this case I am taking quotient as minus 1, right? So number is like this, 5 minus 4, right? So here I'm taking minus 1. So 5 into minus 1 is nothing but minus 5, right? So if it is minus 5, right, so now here in the remainder what I'm going to get here, so what we have to do, how we solve this? Minus 1 and here we have minus 1. So it's like this now. Like here, let's suppose if you have 42, 5 into 8, 40. So you are subtracting these two, 42 minus 40, then you're going to get a 2, right? So here same way, these two part minus 4 minus 5. So what is this? Minus 4 plus 5, and this is nothing but 1. So this is your remainder now in this case, which is nothing but positive remainder, right? So much maths. Okay, simple maths, but right. So this is nothing but positive remainder. Here we are getting negative remainder, here we are getting positive remainder, like this, right? I have proved that both are right. Okay, this is nothing but positive, this is nothing but negative, right? But in programming languages, what you can do here, so you are going to do this minus 4 modulus with the 5. So you are going to get some negative remainder here of this value, right? What you need to do here in this, just add, right? So here let's say this is nothing but a number. Okay, if I write it in common terms, number modulus with the value that you are doing. So whatever is the value you are going to get here, just add the value one more time and then again take the modulus. So you are going to get always positive remainder. So -4 modulus with 5 plus 5 overall, then again modulus with 5. So here -4 modulus with 5 is nothing but -4 negative plus 5 modulus with 5. So -4 plus 5 is nothing but 1. 1 modulus with 5 is nothing but 1. Like this, right? So I just change it to positive. Why I am doing this and then I am adding value? So this number can be large enough. So -42 modulus with 5, right? So what you are going to get here, 42, 5, 5 into 8, 40, right? So -42, and here if you do 5 into -8, so -40, right? So what you're going to get here, you're going to get -2. So you can write it like this now, 5 into -8 plus -2, right? Something like this. So this is a negative remainder, right? So negative remainder, right? Negative remainder of this is nothing but -2. So if you write -2, then add 5 and then you do the modulus with 5. So you are going to get 3 modulus with 5, that is nothing but 3. So 3 is nothing but a positive remainder of this, right? So 3 is the positive remainder. So that is nothing but 5 into you have to do -9, right? And then here plus, and here you have to do 3. So that is nothing but -45 plus 3, that is nothing but -42, right? Clear? Both LHS and RHS is matching, right? You can do like this, but this is clear, right? We have to do this, right? Okay, let's come back to this particular example. So much maths with it. Okay, so here see, in all these numbers, right? -4, 1, 6, 11, or 11 plus 5, 16. So 16 modulus with 5, again you are going to get the remainder as well. So here, if we know the remainder, right? If we know the remainder here, right? If we know the remainder, right? So from this remainder, if the whatever the value we have, right, and k, some k value, right? So I can get 5, I can easily get 11, I can easily get 16. From this I can get -4 also. How? Right? How I'm going to get that? So let's suppose value, if you value is fixed, right? Value is 5. So now here, if k value is 1, so 1 plus 5 into 1, that is nothing but 6. So you can easily get 6, right? You can easily get 6. So here see now, -4, 1, 6, 11, 16. -4, 1, 6, 11, 16. Okay, now if your k value is 2, so 1 plus 5 into 2 is nothing but 10, 11. So we can easily get this. If your k value is 3, 1 plus 5 into 3, 15, 15 plus 1, 16. We can easily get 16. If your k value is, let's suppose, -1, 1 plus 5 into -1, -5 plus 1, that's nothing but -1. We can easily get this, right? So for any k value, right, for any k, we can easily get all these values, right? So we just need to find out the remainder. We just need to find out the remainder. So if I know the remainder, right, so for any value of k, I can easily form all these numbers, right? Whatever the numbers I have, these are all numbers are valid, right? These all numbers can be there in my nums. I can easily form them if I want, right? I can easily form all these numbers, right, if I just know the remainder, right? This is what I'm saying. Okay, so do one thing here. Mine here, this is your nums, right? 1 minus 3, 1 minus 10, right? What is this? 1 minus 10, 7, 13, 6, 8, 7, 13, 6, 8, 7, 13, 6, 8. This is your nums array, right? 1 minus 10, 1 minus 10, 7, 36, 8, and value is equal to 5 in this case. So value is nothing but 5, right? So 1 modulus with 5, I'm writing the remainders, right? And here value is equal to 5, right? Value is equal to 5, right? So whatever the numbers you can take, right? You can take any number. Let's suppose 10 modulus with 5, you're going to get 0, right? 7 modulus with 5, you're going to get 2. 13 modulus with 5, you're going to get 3. 24 modulus with 5, you're going to get 4. Take any number. 26 modulus with 5, you're going to get 1. So see, all these values are in this range. 0, 1, 2, 3, 4, that's it, in this range, right? Value is equal to 5. All these values are in this range only, right? If you do the modulus of any number, you're going to get 0, 1, 2, 3, 4 until value minus 1, right? Only these values are possible in the remainder, right? And we are taking positive only, right? So here 1 modulus with 5, you're going to get the remainder as 4. 1, remainder is 1 here, right? Okay, minus 10 modulus with 5, you are going to get a positive remainder 0 only, right? Clear? And 7 with 7, you are going to get 2. 13 with 13, you are going to get 3. With 6, you are going to get 1. With 8, you are going to get 2. So these are nothing but the remainders that you are going to create. Okay, so here in the remainders, if you see, 1 is occurring 2 times, 0 is occurring 1 time, 2 is occurring 2 times, right? No, 8 modulus 5, 3. So this is nothing but 3, sorry. So 2 is occurring 1 time, right? And 3 is occurring 2 times, right? Am I missing anything? 1 is occurring 2 times, 0 is occurring 1 time, 2 is occurring 1 time, 3 is occurring 2 times, right? So these are the nothing but the frequencies, right? These are nothing but the frequencies, right? So we have to turn the minimum positive integer, right? Minimum positive excluded number, right? So 0, 1, 2, 3, 4, 5, 6, minimum one. So let's say here 0 number, it is there or not? Tell me. 0 number, can I form 0? Right, I can form 0. I can easily form 0, right? Here if you see, we have minus 10, right? So if in this minus 10, if I add the value 2 times, right, value into k, so remainder of this one is nothing but 0, right? So 0 plus value is nothing but 5 into k if you do, right? So you are going to get what? If you do it k value 0, right? So you are going to get 0 only, right? So 0 is possible as of now, right? So this minus 10, right? So here minus 10, right? If you divide it with the value, so 5 into minus 2 is minus 10. So see, you're getting a cosine remainder only, right? So you can easily write it like this: 5 into minus 2 plus 0, remainder is positive, right? So 0, so 0 remainder is there. So if we have 0 remainder, so what are the numbers that we can get? We get 0, 5, 10, minus 5, minus 10, all these numbers. So 0 is possible now. 0 is possible, right? So definitely if 0 is there in my remainder, so that simply means I can easily form this number, right? So let's note this is not my result. So here 0 is possible, right? Next time I am moving to this one, right? And one more thing, here I have used this one, I have to remove it. Reason, with use of this number minus 10, I was able to get the numbers like this: 0, 5, 10, minus 5, minus 10. So if I used this number minus 10 to get this 0, right? If I used this number already, I have made this number to 0, right? Then I can't form this 5, 10, minus 5 and minus 10 if I use this number to make 0, right? So if I've already used the number, right, so that simply means this 0 remainder I have used. This 0 remainder was 1 time and I have already used it. So I have to reduce the frequency of this one, right? So now I'm going to delete it. Next time I'm going to check if 1 is possible. Okay, 1 frequency is 2 times and 1 is already here 1 time, right? So let's use this. So if I'm using one time, so let's say I'm using this number. So now the frequency of this one I'm going to reduce to 1 and 1 is possible, right? Done. Now I'm moving to 2. 2 is possible, 2 is occurring 1 time. So here, yes, 2 is occurring 1 time. So this number 7, right? So with this 7 I can form 2, 7, 7 plus 5, 8, 9, 10, 11, 12 and 2 minus 3. All these numbers I can form, but I'm using this 7 to form 2, right? So if I'm using this 7 to form 2, so 2 frequencies one time I'm already using it. Done, right? 2 is also possible. Done. 3 3 is occurring 2 times, right? So let's say with this 8, 3 I can form 8, I can form minus 2, right? 8 plus 5, 9, 10, 11, 12, 13, right? If there's calculation mistake, then you can correct, right? So but you clear with the logic, right? So let's say I'm using this 8 to form this 3, right? So then the frequency of 3 I'm going to reduce to 1, right? Now I'm moving to 4. Now tell me, 4 is possible? 4 is not there, right? How I'm going to make any number 4? That remainder is itself is not there, right? So 4 is the output for this one, right? So here if you see, so much calculations we did. So see, output is 4 here, right? Same way here in this case, again if you calculate the remainders, right? So let me use some other pen. So here 1 modulus with 7, 1. What is minus 10 modulus with 7, right? So minus 10 modulus with 7. Now let's calculate this. Minus 10, 7, 7 into 7 into minus 1 if I do. So I will get minus 7, and minus 10 minus 7 is nothing but minus 10 plus 7 is nothing but minus 3. So minus 3 is the remainder, right? But I need the positive remainder, right? So what I'm going to do here, I'm going to write like this: minus 3 in this, I'm going to add the 7 and then I'm going to take the modulus again. Same formula, right, that I told you. Num modulus with the value, whatever the result you are going to get, just add the value and then again take the modulus with value. That's it. So you are going to get minus 3 plus 7, 4 modulus with 7, and you are going to get 4 as the number. Okay, let's do 4. 0. 13 modulus with 7 is around 6, I think so. I hope so. Again 6, right? And here 1, right? 13 modulus with 7. No, 13 minus 7, that is 8, 9, 10, 11, 12, 13. Yeah, 6. I'm correct. Nice. Okay, so now again you have choices 0, 1, 2, 3, 4, 5, 6, 7. 0 is possible, right? 0 is occurring 1 time, 1 is occurring 2 times, then 4 is occurring 1 time, then 6 is occurring 2 times. This is what I have, right? Let me move to some other pen now. 0 is occurring 1 time, 1 is occurring 2 times, 4 is occurring 1 time, 6 is occurring 2 times. Okay, so 0 is possible, right? So 0 is possible, right? Okay, so let's say uh, 0 here now. So let's say I'm 0, 7, 14, all these numbers I can form. So I'm using this number to form 0. So now 0 I have already used it, right? So if this number I used it, so now I can't use the same number, right? So this is done. Next time we have 1 here. So 1 is possible, yes. So here if you see 1, let's say I'm using this, right? So 1 is possible. Let's see 2 is possible or not. 2 remainder 2 is not there, right, anywhere, right? So I can't change any number to 2, right? That's the simple meaning of this. So 2 number is not there. So that's it. So this is our output. That's it. Okay, so minimum number we are getting from here, right? And we have to make sure that it should be maximum also, right? So that's it. That's it. Maximum, minimum excluded of an array. So I hope that you guys are clear with the all the examples and what is the thing that we are doing here, right? So that's it. Code is going to be very, very small for this problem, nothing complex, right? So let's write the code now. Let's move to the coding part. Okay, here what is the first thing that you need to do here? Create one frequency array. Let me just maximize the screen. Int frequency is equal to new int, and here I told you that our values is in this range only, right? So that is the size of array that I'm creating. Step one is build frequency array of remainders, right? So for int num in nums, right, I'm using enhanced for loop, and here I need positive remainder, right? Is nothing but it is equal to here num modulus with value, and here again modulus with value, and here again modulus with value, right? So here I am handling negative nums, and then here I'm just going to update frequency of remainders by 1 plus plus. Okay, incrementing the frequency. Step 2 is nothing but try to build a 0 1 2 3 using available counts. So we have to return the max value, right? Int this minimum excluded max, right? So initially it is 0. Okay, and then I'm just going to run one while loop while we are getting true. Okay, while we didn't stop, right? I'm just going to run it, okay, until I break it. So here remainder, how we calculate the remainder? So let's say 0, and here I'm just going to do the modulus with the value. So 0 modulus with the value, right? So here I'm going to check if, right? So if frequency, okay, frequency of remainder value is greater than 0, right? See here. So here 2 was not possible. Okay, 2 was not possible, but let's say 2 is possible. Let's say 2 is possible. Here 3 okay, so let's say 3 is also not possible, right? Here if you see, let's say 3 is also possible, let's say. Okay, 4 is also possible, 5 is also possible, 6 is possible, 7 is possible, let's say like that. Okay, so here 0 is possible, right? 0 is possible. So let's say 0 frequency is 2 in this, in my case. So if 0 frequency is 2, right? If 0 frequency is 2, so if 0 frequency is 2, okay, so that simply means that I can change this 7 to 0, and there is one more 7 here, let's suppose. Okay, then when I reach here 7, so now am I searching for 7 value in my frequency map, or I am searching for 0? Tell me. If for this 7 I want to solve, then am I going to search for 0's frequency in my remainders or 1? So because I have to search for 0 only, right? Because 0 modulus with 7 is 0, and 7 modulus with 7 is also 0, right? So that is the reason first I'm doing this max modulus with value as a remainder, then I'm going to search the frequency of that particular remainder. That's what I'm saying here, right? So if this value is post true, right, then what I'm going to do, frequency of this, I'm just going to decrement it, and then I'm just going to move to the next max value, right? So use one number of this remainder and then move to next max. And if in any case if this is not there, then we have to simply break it, and we are going to exit. No number left to form this max, right? And here this while loop ends, and here I'm returning max. That's it. Very simple problem, right? Okay, so now let's run it and see if there are any code issues. So yes, there are some issues, so let's fix that. Okay, so here what is happening? So num modulus with value, and here why I'm writing modulus value, it should be plus value then modulus value, right? Now let's run it again. So now see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? And what is going to be the time complexity? So here we are just iterating over all the elements in my nums, right? So I can say O of n, and here I am running this while loop until I break it, right? So linear only, I can say the time complexity you can say is of n only. So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.